So finishing off these notes in reference angle. Now reference angles are so important, it's why we're spending a lot of time on this. Negative 280 degrees. So right there's negative 270. Negative 280 is right there. Again, the reference angle is the angle measure to the x-axis right there. How much is that? Right here. How much is that? Well, if this was 10 degrees from the x-axis, this must be 80 degrees. So beta reference is 80 degrees. For 605, we know that 605 is larger than 360, so we're going to go all the way around once. That's 360. We'll subtract there. It's 245. And we've got to go 245 degrees more. So 245, that's 180. 245 is right there. Well, we know if this was 180, I don't know where that went. Draw it again. If this was 180, how much farther did we go? Well, we got to take 245 and subtract from 180 to get 65 degrees. So again, that's the distance right here, right there, and we know how long that is because we already went that 180 degrees, so we got to subtract from that. This last one, negative 410, negative 410 is going the other way, so we'll go 360, which means we really add 360 to get us 50 degrees. So we have another 50 degrees to go. Well, if that was another 50 degrees, that is the reference angle. So our reference angle is 50 degrees. Looking at the last exercise, the whole reason that reference angles are important is because this is going to help us find the exact values of the sine, cosine, and tangent. So if we look at 135 degrees, we know is right there. Exactly halfway in between. Meaning that our reference angle is 45 degrees, which creates this 45, 45, 90 triangle. Which means that this is 1 over square root of 2, and this side is 1 over square root of 2. The sine value, because sine of 135 is the y value, we know that this is equal to 1 over square root of 2. One of the things that we can look at is what would the cosine be? Well, we know since it's in the second quadrant, it would be negative 1 over square root of 2. Again, all based on the location of this triangle, and the idea knowing that our reference angle is 45 degrees, we can create our 45, 45, 90 triangle. Cosine of 240, well, 240 degrees is right there. How far beyond 180 did we go? Well, we went 60. So if we create this triangle, the green portion, that's 60, this is 30, and you need to know those angle measures. We know this is negative 1/2, this is negative square root of 3 over 2. Again, going back to that triangle, if you need to go back in your notes, it's fine for right now. You're going to need to have those memorized. And so cosine, the x value is on the x-axis, the negative 1/2. If we're looking at sine of 240, we could look at the y value, which was negative square root of 3 over 2. Okay? So again, just creating those triangles, but knowing those reference angles are so important, so it gives you which triangle it is. We're looking for negative 60, so we know negative 60 is going down that far, which leaves us 30 degrees there, or 30 degrees here, 60 degrees there. And so therefore we know it's another 30, 60, 90 triangle. This is 1/2, negative square root of 3 over 2 here. And tangent, we know that tangent is y over x, and therefore y, negative square root of 3 over 2, over x, 1/2. That's what this is equal to. Same denominators, therefore we're just looking at negative square root of 3 over 1. Which is just negative square root of 3. One of the last things that we are going to look at is a chart that you don't have written anywhere, but you can draw it in. The last thing that we're going to look at is a table. I know you guys have a table. I'm creating a very poor one here. You're going to see a pattern here, but let's just look. We have a unit circle. The sine value is the y value. What is the y value at 0 degrees? And the answer is 0. Let's look at the next easy one, all the way down to 90 degrees. Right here, 90 degrees. What's the y value at 90 degrees? Well, we went up a whole 1 radii, so it's 1. So now we can look at the 30, 60, 90 triangle, and we know that the 30 degrees was the shorter side, so we know that sine is 1/2. And we know that 60 was the longer side, square root of 3 over 2. We've done enough of those that start to become familiar. 45 degrees, well, we know that was the isosceles triangle. That was a 1 over square root of 2 or square root of 2 over 2. Showed you why that was in the previous video. Cosine, let's look at cosine. We'll do cosine in blue. Cosine of 0, well, cosine's the x value. The x value, how much did we move over? 1. So cosine's 1. What is the cosine value, or what's the x value at 90 degrees? Well, we didn't move over any, so it's 0. Notice what happened here. They switched. Cosine of 30 degrees ends up being square root of 3 over 2. Cosine of 60 degrees ends up being 1/2, if you go back to your triangles. And 45, we know as isosceles that the x and the y values are the same, so it's 1 over square root of 2 or square root of 2 over 2. And then tangent, we'll use it as red, is y over x. All you're going to do here is divide 0 and 1, or 1/2 and square root of 3 over 2. 0 divided by 1 equals 0. 1/2 divided by square root of 3 over 2, the denominators are the same, equals 1 over square root of 3. 1 over square root of 2 divided by 1 over square root of 2, well, the same thing divided by the same thing is equal to 1. You can see here square root of 3 over 2 divided by 1 over 2 is equal to square root of 3. The denominator is to cross off. Then 1 divided by 0 is undefined. It cannot be found. And so therefore, you just found all the exact trig values for sine, cosine, and tangent for the main angles 0, 30, 45, 90, 60. You can now find any quadrant based on if you can find the reference angle and then in which quadrant it is. If sine is positive in the second quadrant, cosine is positive in the fourth quadrant, tangent is positive in the third quadrant, and they're all positive in the first quadrant. This was before in the notes that I skipped, but we can look at all-star trig class if you want a mnemonic device to figure that out. All functions, just the sine function's positive, just the tangent function is positive, or just the cosine function is positive in those specific quadrants. And so we can also see one other pattern, and then we'll end the video here. If you think of counting on your fingers, 0, 1, 2, 3, 4, if you divide them all by 2, the square root of 1 is 1, square root of 2, square root of 3, square root of 4 divided by 2, well, square root of 4 is just 2 divided by 2, and that's how you get 1. So 0, 1, square root of 1 is 1, 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, but we just know that's equal to 1. And cosine is exactly backwards of that. It goes 4, 3, 2, 1, 0. So there is all of that. Hopefully you get a pretty good understanding after you do the work that goes along with this unit. We'll see you in class.